Right, so different loops in Java then. So the while loop is the first one that the book addresses, so we'll do the same thing. There's 3 or 4 different loops to deal with. Some are more common than others, as you'll see. But basically, I'll just put in the comments here, like this, the structure of a while loop is that while, and then something in brackets that evaluates to a Boolean expression, true or false, then perform these steps, then do the loop again, and check that Boolean expression again. So it's basically all about loops, obviously repeating things multiple times while a condition still, stands. So here's a fairly obvious example. Here we've got this integer that we've called loop counter, and we're just going to increment it every time through the loop and print out what iteration of the loop is. So we're saying while the loop counter is less than 10, print out print out what it is, and then increment it. So it'll start off at 0, then it'll become 1, etc. So if we just run that, the loop tester. So there we go. You see, we've got the output there. It's just printed out for every iteration of the loop. And just out of interest here, I don't know if you know what would happen if we took those, because here we're basically, what we're doing, to make it more human readable, we're starting at 0, but we're printing off loop counter plus 1 to make it more readable, so it's iteration 1, 2, 3. Otherwise it would start at 0. It's not a big deal, it's just to make it more human readable. We're adding 1 to it when we in the print statement, but I don't know if you know, because I don't think we've covered it yet actually, it comes in chapter 3, but if you were to do that, it would have a different effect, because the plus operator here, if you remember from operators, works differently when it's all strings you're dealing with, and because this starts with a string, it's assuming that all these are going to be strings, so it won't print in the same way as this. It'll print like that. It's treating 1 there as an actual string, and so the output becomes different from what you expect. By putting brackets in there, you're forcing it to evaluate that as an int first of all, then it will concatenate it to strings afterwards. In the bracketing, you're forcing it to deal with it like an int, then this concatenation after will make the whole thing a string. We'll deal with that more in chapter 3 when we're doing about string manipulation anyway. It's just an aside. And then let's just put that in here, so that this, after the while execution, it marks the point where we exit the loop there. So after while execution, just to show that if we just make that 10 to start with, it would never execute at all. We just come straight to here and never execute, because of course it's that condition is never true there. With while loops, you have to be careful of infinite loops. So let's just show what we mean by that. Just uncomment this. So far, this one here is exactly the same as one before. You can ignore that string for a second. We're just saying this is exactly the same as it was before. So loop counter, while it's less than 10, print this out, then increment it 1. So just print that. Here it's hello world this time, so it prints that string and then the number after it. I'll just comment this one out just so it doesn't confuse our output. Wrong line there and there. Right, but if we forget to increment it, it's been behaving a bit strange at the moment, this is, but if we forget to increment it so that comes out, then that will just keep on going infinitely, because the loop will always be 0. So you can see that's going and going and going and going there. It's just going over and over and over again like that till we stop it. And what we can do is we can do something like this as well. We can make the string concatenate against itself like that. So we're saying that string hello world, every iteration of the loop equals itself plus itself, so it's going to kind of double in size every time. An alternative way of doing that, if you remember from compound operators, is like that: plus equals string plus string is the same as string plus equals string, but that's an aside. That's just like a hark back to earlier in the chapter. So now if we were to run that, we'll see that string sort of getting it's not yes, but that's fine, but it's not actually printing it there. Let me get rid of that, because we went into an infinite loop the first time there. So let's print that again. What you'll see is +1. It's not going in there. Loop counter +1. Right. The machine is behaving a bit strange here actually, but let's just give that another try. Yeah, I can see what's happened actually. It's because it's in an infinite loop already here, so it's never coming out of there. It's not outputting anything. So if I stop that and start again, we should get into this loop now. There we go. So it was just executing that one over and over and over again, because I've forgotten to comment it out. So this time we're incrementing, making the string twice as big as it was last time, and we're incrementing it like that. So what we showed before was that if you don't have a loop counter, that becomes an infinite loop. But this time, because we're concatenating a string every time, it'll fail for a different reason. It'll fail because, well, I'll run it and see. It keeps trying to increment the string like that. Then in a second, it should just fail for another reason that's not the infinite loop reason, because of that out of memory error. Because it's infinitely building strings in memory over and over and over and over and over again. It's building strings, bigger and bigger strings each time, and eventually it runs out of memory. So that's just two things to look out for in loops there. But basically, as long as you make sure the loop's not infinite, then shouldn't run into those problems there. And then let's come here again. Just get rid of that. Also, right, so far we've just created our own loop counter variable, just purely for the purpose of counting through the loop. But you can of course base it on something else, like for example the arguments you pass in at runtime. So here we're saying the args. Remember the string args argument that all the main methods have? These are things that you can pass in at runtime. So it's basically saying the size of the arguments is args.length. That's how many things you've passed in. And while the loop counter is less than the arg size, it will print the value of that argument. Now at the moment there's none in there. So what we'll see with that, I think we'll probably just see nothing come out of that there, because we haven't got any arguments in there. But if we add some, and in IntelliJ you can do it by doing this. It's WhileLoop tester, this thing, isn't it? WhileLoop tester. You can just add some arguments in there. So I'll just do a few of us like that. Just add those in. And run that. There we go. So it's gone in there and printed all those arguments, and you've based the loop counter on the size of your object there, while the loop counter is less than the whole size of the args that you've passed in there. So that's a while loop. It's fairly straightforward. And another one which is much less common, but need to note for the exam anyways, is a DoWhile loop. So if I just, I think I've got this package called loops here. All these classes are in this loops package here. So if we go DoWhile, now this actually is very, very similar to while. I've just given the structure of it up here. It says do and then something while a Boolean expression is true. So it's almost like a while loop on its head. And so here, for example, if I just run that one, it's saying here, do these statements here while the loop counter is less than 10. and you can see the loop counter is 100, so that's never going to be true. And this really illustrates what do-while loops are used for. They basically guarantee that the body of this statement will be executed at least once, because even if this is false the first time round, it'll still do this first. So if I just run that, it's just like a while statement that's guaranteed to run at least once. So there we go. It's saying this is iteration 101 of the DoWhile loop, which is nonsense, of course, because it's actually the first one, but it's based on that. And as soon as it reaches the condition, it fails. And I won't bother running this next one, but it's basically exactly the same principle as before. If you don't increment a loop counter, this is infinite, because this will always be true. Loop counter will always be 0 because you're not doing anything with it, and so this will just keep going over and over and over and over again. So that's another infinite loop there to avoid. Yeah, so we're saying here DoWhile provides a guarantee that statement will be executed at least once. Now this, yeah, so just to show that you can make DoWhile loops execute exactly like while loops if you want to. So here we're saying this is a while loop again here. So we're saying x is starting at 2, while it is less than 10, print this out, and then decrement the value of it. So let's just carry on with that. Let's get rid of that. Say 20 there actually. There we go. So that this time it's counting down. Just for a bit of variation, we're doing minus minus, so counting down. We're saying that it starts at 20. As long as it's greater than 10, keep doing this, and each time reduce it by 1. So that's a while loop, which we dealt with before. But a do-while loop, we could do the same thing. But it's guaranteed. Right, I now see why we did this as 2, because if you do that as 2, that's never going to run. That's never going to run. Whereas a do-while loop, it will run once. So if we run those together, yeah, you can see that this one it ran. It didn't run at all. We didn't get anything generated from a while loop. But we did exactly the same expression, but in a do-while format. It did do it once because they're guaranteed to run exactly once. Well, this might seem obvious, but you can add an if statement to make sure that you never even get in this do-while loop in the first place. So if x is greater than 10, so only do this if x is greater than 10, because it makes no sense to do it if it isn't, and then it won't. Then that won't work. So this do-while loop now behaves exactly like this while loop. But of course, I mean, the book explicitly says that, which is why I've shown it here. But of course, if you wanted a do-while loop to behave like that, you'd never bother doing a do-while loop in the first place, because it's just extra code. You just do the while loop in the first place. So there's no point in having a do-while loop and then controlling the entry into it like that. Although you can do it, but it makes no sense to do so. But you can do it. It's just showing that you can do these things if you want to. And I would say that in Java classes in general, you probably see a while loop in 1 in 10 Java classes, probably possibly more. You see it very, very regularly. A do-while loop you almost never see, but they do occasionally crop up. But compared to while loops, they're massively rare, really. And here's another very popular one, for loop. This is possibly even more popular than a while, actually. And the format is simply this. There's 3 parts to it, separated by semicolons. You have an initialization, a true or false expression, Boolean expression, and then something that happens, an update every time the loop runs. So just let's go into it to see what that means. So this is the initialization. We're saying we're going to have this int I purely for this loop. So it's initialized right then and there. Int I, typically I, because I for index. So int I, and we start at 0. Then the Boolean is while it's less than 10, and then the update is incremented every time. So you're basically saying start with a variable I on 0, increment it every time you go through the loop, and then exit the loop when it's when it's greater than 10, equal or greater than 10. So just do that again. It's fairly straightforward there. For loop tester there. And there we go, so it iterates through 10 times, as we've said, stop at 10 there. Just to say as well, if you remember from earlier in the chapter, like all those weeks ago, you can have post and pre-increment operators. So this is, we're using a post-increment operator there. And when you're doing mathematical solving of equations and things, it's important which order, which one you use. But here it makes no difference at all here, because this part of the for construct, it just behaves in exactly the same way. So if we do this here, we'll get exactly the same behavior there. Doesn't matter which one you use, in other words, so it's same output in both places. Now you can use multiple variables in for statements if you want to. So we've got and we use a comma. So remember, we need the semicolon to separate the three parts, but a comma can be used if you want to do extra things. So here we're saying give me an int I, start it at 0, and j start at 0. The condition is when I is less than 10, and at each point increment I and make j equal to itself plus I. Again, we got that shortcut operator there, that compound operator. So again, if I just print that one out, and it prints out the value of j there. We can add something else here as well then. So we can say, and we can use, if you remember these logical operators, you can say j is less than 40. So if we run that again now, we wouldn't expect that last one to print out now, because we're putting a double condition on there. We're saying I is less than 10 and j is less than 40. When that doesn't prove true, then stop the loop. So we're not expecting that 45 this time. Yeah, it stops at 36. There we go. Again, like before, we can use our args or anything else. Just args is a convenient one to use. We can use any collection, a list or a map or anything, an array, anything. But here it's just convenient to use args.
John, when does that increment take place on line I and j? Is it when it hits the end of the brackets?
Yeah, that's right. So it'll do everything in the body of the for loop, and then when it comes again for the next iteration, it'll do this. It'll do this. So yeah, basically at the end of every execution of the loop. Yeah. So the very first time it won't touch those. Then the second time it will do that. Third time, etc. Like that. And here we're using like the args again, what's been passed in as program parameters. So the first time I expect that to print nothing. Obviously it's printing the previous things, but it's not printing anything here. So if we add a few things again here, we go to edit configurations, and this is a for loop tester. Add a few things in there. So if we do this time, apply that and run. And this time it will just do that as before. So the last one really is a for loop, but they call it a for each loop. It's basically a shortcut. It's a shortcut for doing a for loop. So just to explain, we've got this class here. Almost everything's commented out, but all you need to know at the moment, there's this method called printout, and it'll just print out what you send to it. Notice there's no, this is just an aside, there's no access modifier there. This is using default modification access. We could add one like public or whatever, but that it'll be covered in a different chapter. But for the moment, that has default access, so it'll just print whatever message you send it. So let's just uncomment this now. So we'll create a message of itself, and then we'll call that printout message on it. So don't forget, that's not a static method. So you can't just call it directly. You have to call it through an instance. So this is like going back to chapter 1 really. If we just try to call printout without having an instance of it, it would say, you know, you can't access a non-static method from a static context. So we created a new version of it, and then we're going to like you know, print out what's in it, and this is just the ordinary way we've already covered. The ordinary, we'll do an alternative in a minute. This for each loop. So let's just get that one and run it. Again, so there's nothing in it so far. That's simply because we haven't got any command line arguments. So just put some in there. So 1, 2, 3, like that. So that's printed those out like that. So what a shortcut loop is, or a for each loop, it basically it cuts down on the code you need to write, because for example, you know that args here consists of strings, because here it says so right here. It's a string array called args. So we don't really need to go to all the trouble of creating a variable separately here. We can basically make the whole thing smaller like this. So, oops, behaving a bit strangely this. Yeah. So here, this is a shortcut loop. So we're basically saying, okay, we have our and it can be any kind of collection object, you know, collection. So I mean by that an array or a list or a map or anything like that. But what you're saying is, here I've got a collection of things, and I know that every member of that is a string. So therefore, for every string in this, do the following. So it's basically just cutting down on the code, because you know that contains nothing but strings. So you're saying, give me a string S, give me a string, call it S, for every member I have in that collection. And that'll do the same thing as before. So it should, yeah. So we've got exactly the same output for both of them. So we've almost finished chapter 2 finally, after all that big break. But there's a few more things in the book here. So we've got a while loop, DoWhile loop, for loop, and then a kind of shortcuts loop, or for each loop they sometimes call it. Just that structure there, and we'll get more familiar with these. Obviously, we're just introducing them here, but in later chapters we will use these as a matter of routine. So you'll get more used to them later on. There's just a few more concepts. So this is all like flow control using loops and things. There's a few more advanced control sort of concepts here that we use in loops, and this class has just been done to demonstrate that. But I've got a note to myself here: create data so these can actually be run, because I've set up a few examples here. So today, but there's no, but it would require data setting up behind the scenes, which I haven't done. But I'll have that ready for next week to actually run these and show you. Because if I were to run this now, there's no data there. You see, I've got this list of zoo objects. So if you remember back to chapter 1, we had this concept of a zoo with animals in it. So I'm saying, give me a list of zoo objects, and I'm initializing it to null. That's simply because I haven't had the time to create a list of zoo objects. It still compiles like this, but if I had tried to do anything with it, I think you can guess what would happen. Let's advance. So as soon as I try and do anything with a null object like that, you'll get a null pointer exception. So this is just, there we go, null pointer exception, because I'm saying here, oh, get me the size, call this size method on this zoos object, but it's a null object. As soon as you try to call a method on a null object, you get a null pointer exception. So today we can just look at these as code examples, and I'll try and put some data behind these ready for next time. But so what we're going to introduce some ideas of advanced things you can do with loops and things, is with the idea of nested loops, labeling loops, and breaking and continue. So we'll just look into that now. So I've got a list of zoos here. It could just as easily be our args method, but I'm using zoos because they have hierarchical nesting. You'll see in a minute what I mean. So I'm just saying here, right, so say we've got 3 zoos in here, you know, Chester Zoo, Dudley Zoo and London Zoo or something in here, and we're iterating through them and we're getting the name. So this will print, you know, this is Chester Zoo, this is Dudley Zoo, this is London Zoo. We'll print them each time. So that's fairly obvious, using a standard for loop there, going through this list. We deal with lists in much more detail in chapter 4, but for now it's just any other collection class like an array or a map. List is a very common collection class. So that's all very well. So that doesn't do very much. It just goes through all the zoos and prints the names. So now we might want to look at the animals in those zoos. So this is where we can have loops within a loop. So we can say, okay, so we're currently in Chester Zoo, the first one. So here, give me a list. Here I had a list of zoo objects. Here I want a list of animal objects. Okay, so I'm in Chester Zoo now. Please give me all the animals for Chester Zoo. So we're in the Chester Zoo loop, and we're introducing quite a few things here that we'll cover in more detail later. For any collection class, like a list or a map or whatever, or an array list or whatever, you can. There's a very handy construct called an iterator. So you can construct an iterator like this on a collection class, because animals here is a list, and it'll allow you to iterate one by one through it. And iterator has this very nice method like has next. So what we're doing here, we're doing while the iterator has next, while it has something else still in it. Get the animal from it, get the next animal from it. So say you've got 3 things in there. The first time you go in there, has next will return true, but by the time you get to the 3rd one, the iterator knows that you've dealt with everything in it, and it will return false for that. So it's a built-in way of avoiding null pointer exceptions. You could just as easily construct this as a for loop by going like animals.size, as we've done here with zoos.size. But just to make it different, I put a while loop within a for loop. So here we're using an iterator class. If these concepts don't mean much at the moment, don't worry, because we'll go into them with more detail. But all we're basically saying is that once we've gone into each individual zoo, now give me all the animals in that zoo, and print out the details. It's just showing how you can have a loop within a loop, which you might want when you're dealing with a complex data structure. Like a zoo is a complex data structure. A list of zoos is certainly a complex data structure, because you've got several zoos in there, and those zoos all have several animals. So you might want to, you know, do loops within loops, which is all we're doing there. So don't worry too much if the idea of iterator or whatever is confusing. It's just the concept of doing a loop within a loop. And so this, another thing you can do, you can label loops. So here, this is the same thing here. I've reproduced down here, but I've labelled the first loop. I actually tend to do it like that, but then the formatter changes it for you. I've labelled this one zoos loop, and I've labelled this one animals loop. Right, and why might you want to label them like that? Well, it's because you might want to break or out of one of them. Like in this very contrived example, there is one animal in all the collection of zoos called Jeremy, right? And we need to find him. And once we've found him, we don't care. We can exit the loop at that point. So first of all, we go through all the zoos. We go through, you know, Chester, Dudley, London Zoo, etc. Then for each of those zoos, we go through all the animals that zoo has, and we're saying, well, is the name of this animal Jeremy? And if it is, we say, okay, Jeremy's been found, and we can break. We're breaking zoos loop, because if we just did break there, we would be breaking the loop we're in, animals loop. So it would try and find Jeremy in another zoo, and we already know he only exists in one zoo. So we're breaking right out to the outer loop and breaking it at that point. So you can break. So it's basically you say. I mean, you can imagine, like, you might have a list of 1,000 things, and you know somewhere in that 1,000 is something you're looking for, but as soon as you found it, you're not interested anymore. So that's where break comes in. So, and it can be done at this level or an outer level, whatever. And the final thing to cover, and this ends the chapter after that, is what does continue mean? Well, again, this is exactly the same as this here. I've got the zoo loop and then outer loop. A zoo outer loop and an animals loop is an inner loop. And the very contrived scenario here is that we're not interested in snakes, right? So we're not interested in snakes at all. So if we find a snake, we don't want to bother with it. So first of all, we go through each individual zoo. So we're into the first zoo, Chester Zoo. We get all the animals for Chester Zoo, and we go through them using this iterator again. And then we're saying, well, if the type of this animal happens to be a snake, we're not interested. So we use this thing continue. What that does is it says, okay, don't do anything, don't do our system outs, just go to the next iteration of the loop. And what's the next animal? Is it a snake? Well, if it's a snake, again, miss it and go again. What's the next animal? Oh, it's a tiger this time. Okay, in that case, go into this else bit. Then we do want to see details of this animal. So we're saying, so continue is just a way of, it's like filtering in a way. It's kind of saying we're not interested in snakes, so just go start the loop again. Go to the next iteration of the loop. If it's, as long as it's not a snake, we are interested. Let's see the details of it. And what you could do as well, you could, if you see that a zoo has a snake in it and you're no longer interested at all in that zoo whatsoever, you could continue at this level. You could continue zoos loop. So you could continue, so you'd say, okay, there's one snake in this zoo, not interested anymore, let's just go right to here to the next one, let's see if Dudley Zoo has any snakes, and you can do it that way. So you can continue, or you can be more drastic. You can actually break the loop at that stage. You can say, well, we found a loop, we found a snake in this loop, let's just break this loop now and go back. It'll go to the next iteration of the parent loop. Or as I said, if we do that, that means that the minute we find a snake, we just break everything. We're not interested in any animal in any zoos anymore, because with that anti-snake that we completely gone out. So just to iterate again, you can have break like that, and that means that you'll break it out of the loop that you're in, the lowest level loop that you're in. So that will break animals loop in that case. So if you want to break out of the highest one, you have to explicitly do it. So do zoos loop, and you'll notice that doesn't compile anymore. That's because it realizes that if you do a break like that, then this is unreachable. So you can't compile multiple things like that in there, because the compiler will realize that they're unreachable. Because by doing continual break, you're exiting at that point. You're exiting that particular iteration at that time.
So break is the same as break animals loop in this case.
Exactly. So yeah. So those two are the same now. Break animals loop. You can do it explicitly if you want to, but implicitly, if you do break, it'll just break the one you're in. Yeah, so that's exactly the same as that. Yeah.
Continue a bit.
Continue.
Yeah, because if you're saying okay.
Yeah.
Snake.
Yeah.
Continue.
Yeah. So what you're saying is, say you've got 10 animals, right? And this, so the first one comes in, it's not a snake. So it'll print out here, tiger, Terry the tiger, or whatever. The second one, it is a snake. So what we're saying in continue is we're saying we're not interested in printing the details of it. Leave it alone. So it'll come back to the third animal. Third animal might be a lion. So it'll say, oh yeah, lion, Leo the lion. So what in your output you'll have Terry the tiger, Leo the lion, and no evidence of any snake. And that's because we've continued the loop. We've continued the same way. Ignore the snake, but continue the loop anyway. But if we did break, what we get there, animals loop, or just break, it would print out the tiger one, it would print out Terry the tiger, then it would get to the snake, and it would just break altogether. It wouldn't bother with any more of the animals in there.
Use the code, take out the else.
Yeah.
Right, and then do your print out. So you're saying, if not snake, print out. You could do it that way, couldn't you?
So what you're saying like, if this isn't a snake,
yeah.
If the type,
Comment out the else.
Yeah,
The else altogether.
Yeah.
And then you wouldn't have to bother with the continue, would you?
That's true. So you could do so if the type type not equals snake like that.
Yeah.
Then do your printouts there.
Yeah.
Yeah, you absolutely could do that, and of course in the real world you would. But this is just constructed
Yeah, I
to
understand
to demonstrate the principles. Yeah, you could. Yeah, you could do if the state doesn't equal snake, if the type doesn't equal snake, all these printouts could be here. You're right, and you'd be saving a lot of code. And of course, you would really do that because obviously it's better to save code. But it's just showing the principle of continue and break. And I think if you look in our test classes, we do use that quite a bit in automated testing.
What? Continue?
I think we certainly use break a lot.
Yes.
I've seen that. Yeah. Continue, and again, like we were saying, like you see while loops much more often than do while loops. You'll see break much more often than continue. Just generally speaking, really. But
if you had nothing in the top bit of the if statement, it would still work the same anyway, wouldn't it, without the continue.
excuse me.
It
So
would
if
still continue to go through the rest of the animals anyway.
so, if you had what Giles? If you were saying,
If you'd commented out that break animals loop,
yeah. Excuse me.
that would still work the same as if you had continue commented in.
Well, that's right. So it would just do nothing. Yeah, it would just do nothing really, wouldn't it? Yeah, absolutely. So if you had that, it would just do whatever is in the body there, and do nothing else. I suppose typically you might do something else beforehand. You might say, you might do an alternative. You might do something else to clear it up. But I mean, it's a very contrived example, really, and you're right.
I suppose you could say, add one to count.
Yeah,
Just
exactly,
before continue,
exactly.
And then you say at the bottom outside the loop. That's the snakes found.
True. Yeah, you could say this is the total number of animals found, and this is how many snakes there were. And yeah, you're right. You could do something like that. Yeah, that's it. But yeah, kind of nonsensical example. It just shows these keywords really that if we want to do the exam, we just need to know that these words continue and break really, and the fact that you can label loops like that, and you can have obviously loops nested within other loops. Really, that's what this advanced control loop thing is about. So that pretty much ends all the material in chapter 2.